Recording. Hello, everyone. Welcome to Filecoin Core Devs call number 68. We didn't have last month's call, so here we are this month. Today, Thursday, 4th April. It's just about 12:02 p.m. on the Eastern Time. We have two things on our agenda today, supporting Ethereum legacy transactions by Stabilian, and then we have the MV22 upgrade updates. Nothing major. Hopefully we can get it done in record time. But without further ado, I will pass this over now to Steph.
Hello. Let me just bring up the proposal here so I can, thank you. Yeah, so this is just a quick discussion around supporting legacy Ethereum transactions in Filecoin. At the moment, Filecoin supports EIP 1559 transactions by, well, to a complicated mechanism. Basically, we originally intended to add native support for a form of account abstraction. And the idea was to validate these EIP 1559 transactions inside like Ethereum account smart contracts, which I know is a bit of an oxymoron, but effectively we want to put code inside these Ethereum accounts and have them validate their own messages. At the end of the day, we never implemented that, and instead Lotus just validates transactions coming from Ethereum accounts by basically taking sorry, I'm really botching the explanation here. Basically, the way this works is your client, or your tooling like MetaMask, will send an Ethereum transaction to Lotus over the ETH and RPC API. Lotus will translate this into a Filecoin message with a special signature type. Then when we try to validate this special message, we will translate it back into an EIP 1559 transaction and validate the signature. The problem here is that this only supports this one type of transaction, and it turns out some people really, really need legacy transactions. Legacy transactions are basically the old style of Ethereum transactions that existed before Ethereum added chain IDs. So if you sign a legacy transaction with your key, it can be submitted to any chain. If you sign an EIP 1559 transaction, it can only be submitted to the chain that's specified in the transaction's chain ID. However, people really want these legacy transactions so they can deploy smart contracts on any chain at the same address with a single message. So this is really useful for a lot of decentralized finance stuff, and basically any case where you need to deploy a singleton smart contract on arbitrary chains, you can create a single message, sign that single message, and it can be executed on any chain. So that's the idea. The question is, how do we solve this? I've outlined several solutions here at the bottom. There's 4 possible solutions. Well, I guess fine. One possible solution is don't support it, but we have a fair number of users who really, really want this. So the 4 ways to actually implement it are: 1, try to decode both ways. Where we could say, okay, we have this Ethereum message, or this message that's coming from an Ethereum account. Let's try to treat it as an EIP 1559 transaction. Doesn't work. Okay, let's try to treat it as a legacy transaction. Okay, it doesn't work. Okay, signature fails to pass. This is really nasty, so I don't want to do this, but I'm bringing it up because it's technically an option. Another option is to give up on native account abstraction and add a new signature type. So remember when I talked about how the way we do this, our intention was to eventually add native support for account abstraction, and the idea was that the ETH account was supposed to validate the signature for us. To support this, we added a special delegated signature type, and the idea was that it was delegated because we were delegating the signature validation to the account's code. We could just say, forget that, we're never going to do that, because there is a chance, unfortunately, that we'll never get around to it, and basically rename delegated to EIP 1559, and then just add a new signature type called Ethereum legacy transaction. So effectively, these would be top level Filecoin signature types. Unfortunately, that would mean that this support would be baked more deeply into the protocol instead of being something that happens in user space where, okay, technically right now it is baked into the protocol, but the idea is that we designed it such that we could move it into user space in the future when we had time. This would basically prevent us from doing that. I have a question here. Sorry. So there are different types of AA solutions. Ethereum actually does account abstraction entirely in user space. This is much harder for us because of tip sets. It's much harder to implement MEV solutions on top of Filecoin. So that's why it's very difficult for people to actually implement account abstraction solutions, or sorry, entirely user space account abstraction solutions in Filecoin. That's why we wanted to build it into the protocol itself. This adding new signature type would not prevent us from implementing actual proper account abstraction. It would just mean that we would forever have a native concept of an Ethereum account inside Filecoin instead of being able to eventually make it basically you use the account abstraction feature to implement it. That's the problem there, where it just means we have sort of more native support. On the other hand, it is technically an option. The final two options are basically put something in the signature of these messages to indicate which transaction type we have. F4X address type? No.
Right, so like today we have F410 for FEV, the first batch of EVM. Saying can we not just using the address scheme that we have developed for F4 to identify a special one for the legacy for this kind of
unfortunately, this is a different type of transaction, not a different type of account.
Right.
Yeah, the same account can send both types of transactions. Yeah.
I got confused a little bit.
Yeah, so that's why I can't do that, unfortunately. But basically, the last two options are the ones I'm really proposing. The first one is basically prepend or append a byte to the signature field to indicate the transaction type, or even a few bytes here. We can basically just append a unique identifier that tells you what type of transaction this is. This would only be appended in Ethereum transactions. So the idea is if you see signature is delegated, it comes from an F410 address. We know, okay, this is an Ethereum transaction. We can then look at the signature. The first bytes in signature, the first byte in signature would be the type, and then the rest would be the actual signature. The nice thing about this solution is it means that we're still we're not we're still keeping the whole account abstraction potential around. We're not box ourselves into a corner where we were always going to have to support Ethereum transactions natively in Filecoin. But it's also a lot nicer than the try both ways method, because it actually the signature type here now would tell us which way to try. The other option here is that final one where basically the problem with the first option is it's still technically changing the structure of the existing Ethereum EIP 1159 messages that we have on Filecoin right now. So if there's any tooling that's trying to validate these, basically the signature validation will change between one network version and the other, and this could cause some problems. The final option here is to prepend this byte if and only if the signature type isn't EIP 15519. So that basically means that the existing transactions will stay exactly the same. We're not going to break anything that currently exists. We will just add a new way to translate legacy transactions into Filecoin messages by basically adding this additional byte in that one case. I know this is all really complicated, probably requires some context. If you haven't read the discussion, please do and comment. But I wanted to open up the floor here, I guess, for some questions or comments or I don't understands.
Thanks, Derek. There are questions.
What's the downside of option 4? Because it sounded really nice, create the least disruption to the tooling adoption and stuff like that. So what's the downside of that option?
The downside is that it's a little bit implicit, because it means that we won't technically have a type, a byte that indicates the type for these EIP 159 transactions. On the other hand, I actually don't really see a big downside. Okay, fine, add one more byte to other transaction types, which I don't think anyone really care about. And actually, instead of prepending, we can append, which might even make it simpler. Where we say, look, like it's like everything is the same. We just add an additional byte to the end to tell you that this is something else. Yeah, so like I really don't see a downside to this. I guess the real comparison here is really option 4 and option 2. That really is, well, option 4, 2, and 1, honestly. Like 1, try to decode both ways it's technically safe, actually, because it's technically equivalent to options 3 and 4, because basically you can reduce options 3 and 4 to option 1, because this extra type byte is technically not signed by the transaction. Whatever, it's complicated, but it's technically the same thing. So technically we can do 1. The problem there really is the fact that like it now requires 2 signature validations instead of 1, which is not great. And it only like it doesn't really let us extend into additional transaction types in the future. That's why I kind of like option 3 and 4. But option 2 here, the nice thing about that is it's like it does actually clean up a lot of our code, because it means, okay, we're basically giving up on this new potentially complicated feature. We have explicit signature types for these different transaction types. It's very easy to understand what these transactions are. We're not like basically option 3 and 4 effectively have now 2 layers of types, where they have like the top layer of type, which says this is a delegated actually 3 layers of types. You have the top layer, which tells you it's delegated signature. Then you have the second layer, where like you have to look at the sending address to figure out that it is a delegated Ethereum transaction signature. Then you have the third layer, we have to actually look at the signature to figure out which type of Ethereum transaction. And like so, like the problem here is we keep on stacking these additional type layers. The nice thing about option 2 is we're saying, you know what, forget all of this. Like this, like, we basically retcon and say, okay, delegated transaction or delegated signatures are actually just straight up Ethereum transactions, or really EIP 1559 transactions. We add a new Ethereum legacy transaction type, and they're all just top level types. The problem here, of course, is it means that, like, again, as we move forward in the future, we will have to basically continue supporting these Ethereum transaction types in the core protocol indefinitely. So that's really the trade-off there.
Thanks, Steph. Did you want to come in now?
Me?
Yes.
No, I mean my,
No.
my question was the same as Jennifer's, you know, and obviously being the lazy person that I am, the solution I would vote for is the one that works best with the existing people who are having a problem with it.
Okay.
So
yeah, then like really either 1 or sorry, well, 2 or 4 are the best.
Make this the better from my perspective, but
yeah. Okay, so really this is just a big bike shed. That's why I brought it up here. Please like leave opinions on the FIP discussion itself, as well. Like take some time to think about it. It doesn't, like, in many ways it doesn't matter how we make this bike shed. The main difference, really the only thing that matters is if we go with option 2, because that does rule out some potential future use cases, or features we could have. But yeah, thank you. That's really all I have to say.
Thank you. Jennifer, do you want us to take your async conversation now, or you still prefer to
No,
take that?
no, I will just raise it in the discussion if I still cannot think of it later on.
Okay. Great. Are there additional comments or questions? No? Okay. We now pass it over. I think the next item we have is NV22.
Awesome. Yeah, so a quick update on NV22, codename Dragon. About like 1.5 weeks ago, like the implementers team had like a NV22 Dragon Q&A session in the Filecoin Slack and Slido. Got a lot of questions that were quite interesting. Some really good questions there. those were posted in the Filecoin Slack in the Hope channel, and we will summarize those and publish it as a blog post soon. Yesterday, the calibration network also was patch upgraded. So a big thank you to like the community for upgrading their nodes in a short fashion. It was patch upgraded to add 2 additional like built-in actor events to ease the transition and observability for DDO, which was some of the feedback that we got after initially deploying the first NV22 version. And then next week, on April the 11th, the mainnet upgrade will happen. And all implementation teams have like stable releases out. So we're just waiting at this point.
Thanks. Yes, Jennifer.
Thank you, Orion, for the update and also helping coordinate this like upgrade across all these ecosystem teams, users, and implementers. My hand is more for, like Orion mentioned over here, we did patch the calibration upgrade earlier this week. And this is actually not patching for a bug, but actually it's like, in the very late stage of our network upgrade deployment, we received some additional community builder feedback on the certain FIP, which is the actor event FIP that we already finalized and accepted to be included in this upgrade, but they are giving us feedback to suggest that they need additional features of the FIP to be implemented for this upgrade so they can update their tooling and support the network needs. Again, the feedback coming in very late in the stage, literally like 2.5 weeks before the upgrade, which does make us implementers into a very reactive position. Like we have to be responsive really quick, make quick protocol design governance decisions just to make sure that we balance the different trade-off between governance, design, user needs, and all those things. So what I'm getting at here is that, Lucky, it will be really good for us at one point to organize a retro for the core devs, for the implementers, just to reflect how did we do to deliver this upgrade to the community, to the users. I feel like one thing that we will be getting a lot of inputs on is actually on our FIP governance process. How are we gathering peer review and community feedback during the early FIP stage, rather than after FIP is accepted, we have to go back and update that in the later stage. But yeah, I think a general retro can be useful, either async or sync. But yeah, that's my proposal over here.
Thanks, Jennifer. Yes, that's in the plan. I will share around like a retro doc that we can use. I'm happy to put together like a synchronous convening if we prefer. And it'd also be a good time to discuss like pre-scheduled upgrades, being that this is the first one that we're shipping with this pre-scheduled approach, and see if there are also additional lessons we're learning ahead of future upgrades that we're planning as well. So definitely look out for that from my side coming up soon. But thanks for flagging. Are there additional questions or comments? Okay, I think that's the only topic we have for today's call. Again, if you've moved teams or you're planning to move, you're changing your email addresses, do let me know so we can update our records. Otherwise, thank you all so much for coming. I'd like to, shout out to Oren and all of the team supporting. It's been a very interesting upgrade season this time with all of the different changing and timelines and dates. So thank you all so much for being so responsive. And hopefully NV23 wouldn't be as stressful as this one. But anyway, thank you all so much for joining. See you all next month. Bye.
Bye, folks. Thanks.